My name is Emilia. I'm from the Explore.land team, and I will be helping to moderate this session organized by biometrio.earth and CO2operate. With regards to Explore.land, Explore.land is both a platform and a tool for nature-based projects to monitor, show, and communicate their work and impact, and for different stakeholders such as funders and businesses to find impactful nature-based projects. But this session is not about Explore.land. It is about the Food Forest program that aims at restoring forest ecosystems on unused or degraded land through assisted natural regeneration, and is managed by CO2operate together with several local, regional, and international partners. And without further ado, I will introduce our speakers today that will be talking about the Food Forest program, with Paul Burgers going first from CO2operate, pictured here with his first ever book, The Jungle Book, which inspired him about the kind of life and work that he's doing now. And CO2operate is an organization that builds cooperative partnerships to mitigate climate change through multi-benefit ecosystem restoration projects. And then later, Leandro Nascimento from biometrio.earth will give us his talk, with biometrio.earth being an ecosystem health diagnostics and monitoring company that enables a radical transparency in the monitoring and evaluation of nature-based projects. And before we begin with our first speaker, I'd just like to mention again that this session is being recorded. And we will first have our two talks, our two presentations, and then you will have the ability to ask questions. You will be able to unmute yourself and speak out the questions directly, or if you wish, you're always welcome to type in your questions in the chat as we go. And once we're finished with the talks, we will first address any questions in the chat, and then you will have the ability to ask further questions. So we will have a lot of time for this interactive part. So I hope you will have some interesting questions for our speakers. And with this, I would like to hand the screen sharing over to Paul.
All right, can everybody hear me? Yeah, I hope so. Yes, good day, everyone. I just saw in the chat that people are calling in from even as far as Malaysia, New York. So we're all over the globe. So better to say good day to everybody or good evening. Let me start sharing in the presentation mode. Right, so I'm the founder and director of CO2operate, based in the Netherlands, but we are working in Indonesia. We have, as you can see on this slide, a site in West Sumatra, which is our flagship project, and that's where we will be talking about today. We started up in West Timor 2 years ago. We have a project in West Java, and we are hoping to move to Flores next year. So I hope next month I will be in Indonesia to visit the place and see if we can start working there. And we have some contacts in Kalimantan for the coming 2 years. So we are spreading out all over Indonesia, and we hope we can manage to cover all the islands Not sure if I lived that long anyway. So this is our team in West Sumatra working with us. This picture was made in January, but it's now already September, so there's already 3 more people have been added to the team. So we are really growing because our work is really growing and the demand for our carbon credits is really high. So what do? We focus on really a restoration of ecosystems. So as you know, in forest areas has been a lot of degradation caused by logging, illegal logging, formal, informal forms of logging, say it politely. We have forest fires coming in, which has degraded the forest. After that, it is easy for large-scale, small-scale agriculture to encroach into degraded forest areas, quite often with inappropriate types of agriculture, thereby degrading the soils and leaving a really degraded land covered with imperata grasses, as you can see here. Wherever there's imperata or degraded land, that's where our program wants to start and move in to rehabilitate the area. So what we do, I will show you later on, we have a wooden plank. That's the only technique we use to start restoration activities. And within 5-6 years, we will have a food forest back, which a lot of production for farmers, where they can get food, they can get an income from selling the products. And as we found, there's a lot of biodiversity coming back. That's where we will focus on today. So what have we achieved so far? We are over 400 hectares brought back into producing food forests. And this coming year, we will at least add another 50, but probably 150 hectares to our sites. We have worked with 425 farming families at the moment, but depending on what we will achieve this year, 55 to 175 families will be added. So as I said before, we are certified for our carbon sequestration by Plan Vivo. And the latest development is that we are closing the loop. So besides setting up the food forests using carbon investments, we are now helping the farmers to do local processing of their products so that they can get a better income instead of selling the raw materials. So we are now having products, we have coffee Arabica, coffee Robusta, we have Arenga palm sugar, and we are producing clove essential oil, which is slowly being exported into the EU market. And then we will have a profit sharing arrangement with the farming communities. So they will have 3 times income. One is from the carbon credits, one is from the selling of the products which we buy, and then later on we will also share some of the profit with them. In that way, we are reducing poverty in the regions that we work. How do we work? As you can see here, as I said before, it's about pressing the grass, and that's literally what they do. So the weeds and all the plants are being pressed. You can see here the small trees that are existing in the area. They will protect them, so they give them light. They start to grow very quickly. And that's how we start developing our restoration activities. So after pressing, the grasses will slowly decay because it's very humid below. So we are adding carbon to the soil. We let nature do the work. How does that look like if you look at a period of about 7 years? So we start here on the left, degraded land, as you could see the weeds and the grasses being pressed. But what we do is we go around first, we look at the small trees that already exist in between the grass. We mark them with bamboo sticks just to avoid them to be pressed. Just press around it, flattening the grass. You can see after 1 year, these trees start to grow because they already have a good root system. So they start growing quickly once they are giving light and air to breathe. So after 2 years, these are the trees that you can see here. Quite tall already. They provide a good microclimate for other trees to be planted. So the farmers can choose the trees that we grow in our nursery for them. So these are clove trees. You will find fruit trees, spices, all kinds of different trees that they plant in between. And in 7 years, the area looks like this, and it just, you can see the hill here, it's the same as this one. So this is after 6 years already. We have quite a good forest. So if you look a bit more closely into these food forests, this is how it looks like. Quite dense, but still for a farmer possible to walk around and go through it, because here these are clove trees, for instance. They need a ladder to go up and harvest the cloves, so they need some space to go around. There's here pinang fruits. You have these old indigenous trees that we protected in the beginning. There are fruit trees in between. Other farmers have planted, in this case, coffee robusta as an understory, besides fruit trees and other useful trees. And this is a big one where they also integrate banana trees. So it depends on the farmer how he wants to build up the forest. So when we were walking around in these agroforest, food forests, we saw a lot of twigs being broken, small damage to the trees, leaves were eaten. We saw footprints. So as a joke, at that time it wasn't serious. I just thought, well, who is enjoying our sites when we are not there? So we put up 2 cameras, and you can see a lot of monkeys were there making selfies whenever we were not there. Even a deer was trying to make a selfie, not yet very expert in it. But besides monkeys, we saw wild boar, we saw birds, and all kinds of different animals. So then I thought, well, if it's that much, we can of course say for our carbon credit sales, we have proof that biodiversity is coming back. But being a scientist, or in my previous life, I thought this should be done on an academic scale and on an academic approach. So that's where we got connected with the biometrio guys and Leonardo, who will talk later about the results. So in our case, it was very good to do it now, because we have an enormous spectrum of food forests and areas in different stages. So from young here on the left to about 4 or 5 years old in the middle, to fully grown agroforest. So we said, okay, let's cover the entire spectrum on a scientific basis and find out how biodiversity is changing over the years. That's what we did. So with biometrio, we have started to use bioacoustic methods combined with wildlife cameras or trap cameras that we placed in the forest. And our team in West Sumatra, the young guys are very good in all these technologies, so they were able to set it up. And we got some really nice results. So after 1 week, these guys got very excited, and they wanted to see what was on the camera. And already this guy, after the first week, we hit the jackpot with this guy already passing in front of our camera. So we had placed 2 cameras, because it is a pilot project, and the good thing was they were 8 kilometers apart. But still, this tiger came in both cameras. So that means that our sites are also providing very important functions, corridor functions for mammals to move from one forest area to another. So I'm almost finished. But besides the above ground biodiversity, we also managed to look in our network in Indonesia and our university network to find the right group of people to do below ground universities biodiversity. So we started working with Malang University in Eastern Java, doing the field work on the below ground biodiversity. And we had an enormous motivated group of students. You can see the ladies, even dirty trousers, working in the rain. They just continued working very hard. We had a farmer here on the right, some farmers, always happy to have these young people in their village and staying with them in the village. So they're also very interested and wanted to know what we were doing and what they were doing. So we are looking at carbon in the soil here on the right, because carbon will give you an idea of the soil health, but also very important, look at the worms, because worms are really the soil engineers, and depending on the type of worms, you can see whether the soil is improving in health or not. And we found some good indications that indeed the type of worms, when the food forest gets older, are really moving into the type of worms you will find only in forest areas. So also below ground, we see there's a positive change with our restoration activities, but we need a bit more research to really make firm statements about it, but it looks good. While we were doing this biodiversity work, we got hampered by our own success, because the biodiversity in our sites was really hampering our progress, because in one of the sites of areas, the older sites, there were four bee nests from the wild bees. They were nesting in our sites, and what I understand from biologists is that these bees only nest in areas where the forest ecosystem is intact. So that means the old agroforestry or food forest areas really resemble a forest ecosystem. But these guys are very dangerous. And the week before we went into this area, two of the villagers passed away because they were attacked by these bees. So we decided to wait for 2 weeks. So yeah, we were a bit laughing, of course, that our biodiversity enhancement is now hampering our biodiversity work. And they were double aggressive because, as you can see, there were a lot of eagles flying over the site, because the eagles like to eat the larvae from these bees. And yeah, they were attacking the bee nest. So whenever you would come close, yeah, the bees would attack you. But after 2 weeks, when the larvae come out, all the bee nests were gone, because the bees will then fly out and go somewhere else. And after 2 weeks, everybody was able to go into this area and do their biodiversity work. And that resulted in quite some impressive results we never thought of. And to show you that, I think from here, Leandro will take over. Thank you very much. That's what I had to say.
Thank you, Paul. It's always very interesting to see the wildlife selfies and how some are really experts in that and other species not, and also the really impressive results in the older agroforest systems in terms of biodiversity, with biodiversity actually hampering its own assessment because too much of it has returned.
Yeah, it was a bit, we were very surprised also.
And now, Leandro, please, you can tell us a bit more about the biodiversity assessment.
Okay, can you hear me okay, Emilia?
Yes, yeah. You're good to go.
Okay, great. Thanks, Emilia, for the introduction, and thanks, Paul, for the great presentation. So I'm just gonna, with my presentation, as you saw, we partnered with a CO2 operator to conduct the biodiversity surveys. So what I'm gonna do in this presentation is just to show you some of the results we found in this pilot project. So the presentation is pretty much divided in 4 parts. So I'm gonna give you a brief introduction about the biometrio.earth and the work we do, and then I'm gonna dive a little bit about the data collection and how you analyze the data from the West Sumatra pilot project. And then in the end, we're gonna show you the most important part, of course, is the results, what we did find, how many species we found, and some of our take-home messages. So as you saw, even like from the Paul presentation, there is a need to monitor biodiversity more efficiently. And new tech, they plays a large role on GIS. But even the best of the techs, they may fall short without a clear plan and research design about how to set up GIS monitoring systems. And to set up GIS right, you need to have your objectives clear in your mind. So what is the goal of your project? What do you hope to achieve with GIS biodiversity monitoring? Are you gonna conduct it? So you need a clear spatial and temporal framework for your data collection as well. The sensors you use need to be operational, need to be sustainable. You need a very robust data management plan. So imagine you collect data for only 30 days, you have thousands of recordings for analyzing. But usually these carbon biodiversity projects, they may last for decades. So imagine if you're collecting data 24 hours per day, in the end of a couple of years, you're gonna have terabytes of data to analyze. So you need a very efficient way to manage this data. And similar, you need a very good way, a rigorous data processing scheme to process this data to provide meaningful results to your partners, to your clients. And you also need a full documentation of this process, of course, to bring more transparency to the projects, and also clear data sharing protocol, including the data rights and access to the data. So at biometrio.earth, we build on decades of experience from your team to offer the best tech and research design available to date for biodiversity monitoring and just carbon biodiversity projects and nature-based solution projects overall. So we have experience from national biodiversity monitoring systems from Mexico, from Brazil, from different European countries, from Africa, so everywhere. And they use to monitor biodiversity, we offer a range of indicators that go from species level indicators, such as species richness, so basic, how many species occur in your area, to ecosystem level indicators, such as ecosystem integrity indicators. And also you offer different ways to collect this data to conduct this analysis. So we can conduct the data like we did here in this project, camera traps, acoustic sensors, satellite remote sensing, and even some other techniques like such as eDNA and so on. So we offer basically 3 types of products to our clients for monitoring biodiversity ecosystems. So on BioE remote, so biometric remote, we don't deploy any sensors in the field. So all the evaluation is done remotely by satellite remote sensor. You can do land use change analysis, analyze carbon stocks from the forest and so on. On the other hand, in the biometrio in-situ starts, we deploy some sensors in the fields like we did with CO2 operated. So we deploy some camera traps, we deploy some acoustic recorders. So we directly collect some wildlife data from the field. And then biometrio complete, this is the type of product that brings the most transparency to the project. So it's a tailor-made evaluation of the development of the project area. So it's a more comprehensive biodiversity surveys. We offer communication resources such as online dashboards and so on. So what we exactly did from this case study in CO2 operated and why we did it. So this was the first pilot project we engaged in biometrio. So we deployed the equipment for a short period to conduct these tests. So usually we deploy for more longer periods, for example, years, and more sensors. But our goal here was to just test our approach and still provide some meaningful insights to our partners, CO2 operated, to see how this biodiversity was changing if it was in the expected direction that you were expecting, right? So positive gain from biodiversity in just different as the agroforest farms were growing older. So we deployed the sensors in 4 land use types, like Paul explained. So you have degraded forest, so no intervention yet. So you have young agroforest farms, you have old agroforest farms, and as a control to compare with the agroforest farms, we also installed some sensors in secondary forests. So these are more intact forests there in the West Sumatra. So this is just an overall region of the area where the Gula Gula project is located there in West Sumatra. So like I was saying, we deploy camera traps and acoustic sensors in degraded sites, so young agroforest plots, older agroforest plots, and secondary forests as controls. And the way we analyze the data in biometrio.earth is using artificial intelligence. So these sensors that can collect data 24 hours in the field for months, they become a really powerful tool for biodiversity conservation when paired together with artificial intelligence. That's why imagine for, like I was commenting, if you're running the project for 30 days, you get a lot of data. But imagine if you run even for like years, you're gonna get terabytes of data that is almost impossible for a human to analyze manually. So you need to analyze that, take the best of the technology has to offer to try to automate this process of data analysis, to get these different biodiversity indicators and to have a better idea of how biodiversity is changing at the landscape level at your study sites. So what we do in biometrio.earth to both analyze the camera trap image and the audio data, use a type of deep learning algorithm called convolutional neural network. And the way you analyze the data is pretty much split in three processes. So it's three-part approach. So the first one you have to train, which is deep learning classifiers to classify the species you are interested, for example, the Sumatran tiger. So you have to feed this algorithm with some images of Sumatran tiger. And similarly, if you want to classify a bird's song, you have to feed the algorithm with examples of how that bird sounds like that you want to classify. So after you train the algorithm with some of these examples, the algorithm is going to learn some of these features of these sounds and images, and then it's going to look throughout all your database, so thousands of recorders, video, images, and gonna try to assign that video or audio to a specific species, that taxonomical species you want to classify. And it can be a classification in the species level, it can be in the genus level, family level, and so on. And okay, so let's skip to the results. And for the camera trap first, so we found, so as you saw, we only deploy only 2 camera traps, but even deploying just this minimum setup, we are really impressed by the results, especially by detecting the Sumatran tiger, critically endangered species, a very important umbrella species for the region. And of course, if you had more sensors, if you deploy there for longer, you likely would detect much more mammals. But we still detect about like 8 mammals, a couple birds with the camera traps. And I guess the jackpot was detecting the Sumatran tiger. Was the first time was detected there in the study region. So we are quite happy about it. Maybe the people there, the locals, were a little concerned, of course, having such a big target of this roaming around their houses, but it's still great for the project overall. If a tiger is there, it's an indicator species that means that as these old agroforest plots are doing well regarding biodiversity. So besides the camera trap analysis regarding the audio analysis, we did analyze the data in 2 ways. The first one is using some soundscape analysis. And by analyzing soundscapes, you can understand this is to analyze the entire community. So here we are not focused in a specific species, in a specific taxonomical level. You're focusing the whole community of species, because all species that make sounds, they contribute for the soundscape. So all this collection of sounds you can find in a given landscape. And you can analyze that, for example, with acoustic indices. They are mathematical formulas that summarize this acoustic complexity or this region of sounds you can find there in a landscape. So let's focus here in this one that I highlight in green, this one of this acoustic index. And you have different colors, there are different lines to represent the different land uses you surveyed. So in the purple colors, you have the degraded sites. In the greenish color, you have the secondary forest over here. And then in yellow, you have the old agroforest plots. In the y-axis, you have the value of this acoustic index. So in this case, the higher, the better. So the higher, the more species you have in that place, more species in the soundscapes and the landscapes, lower value, less species singing at that time. And then in the x-axis, you have the time of the day. So you took all these months of field survey, we averaged them out by a 24 hours period, and then we computed this acoustic index. It's just an easy way to visualize how the biodiversity may change through the dial cycle, through this 24-hour period. So as you see here, I wanted to highlight only, there's a lot of data over here, right? But the purple, the degraded sites, they always have lower values, most of the time at least, than the other two land use types, the old agroforest and the intact forest. So that's the expected direction we are hoping to see, right? So we expect the degraded sites to have less biodiversity overall than the sites that were intended being restored, such as the old agroforest, and of course the intact sites should be more biodiverse. And as you can see, you can visualize that with just mathematical performance, but if you're curious, you can also hear how that may sound like. So for example, let's take a minute to listen to these soundscapes. So let's start with the degraded sites. Can you hear it, Emilia? Can you just confirm?
Yes, we
Yes.
can hear sound.
Yeah, so you're hearing degraded sites here. There's not much to hear over there. So you see in the degraded sites mostly empty. Maybe there's not many species there singing at the same time. So that's going to reflect in this soundscape analysis here. You're going to reflect in lower values over here, right? If you don't have many species singing at that time, specific time. But let's look at intact forest, for example, now. There's much more going on with that smart species. We can listen for it a little bit, but you see there's several birds, frogs singing there at the same time, so much more rich soundscape. And again, that's going to be reflected in the soundscape analysis, as you see primarily here, with the purple color of that in the degraded sites. So very cool, full of soundscapes. And lastly, the old agroforest plots. So as you can hear, maybe it's quieter, but it's still more sounds than the degraded sites over there. You have a few birds singing now and then, some insects, squirrels in the background, and so on. So the advantage of using the soundscape analysis that it takes all this cacophony, all these different sounds over there, and try to complex and try to summarize that in just one number that we can use, like for conservation purpose, for example, for biodiversity monitoring. So quite relaxing. Let's continue. So you saw that we could see the difference over there across the different sites, the different use, right? Degraded, intact, old agroforest. But you could also detect this change when conduct some more rigorous statistical tests. And the answer was yes. So the sites were sufficiently different that are also showing some when you conduct some statistical tests for differences. That's what this table here is trying to show a little bit. So this is the result, is a confusion matrix as a result of a random forest classification. So different type of a machine learning algorithm, and just pretty much confirm what we are seeing over there in this other graph, the difference we see in the soundscapes across the different sites. And okay, you saw this community level analysis with the soundscapes, but you also can try to get to the species level, analyze the audio. And that's what we did using the convolutional neural network classifiers. So we trained that mostly to classify birds because that's one of the most studied taxons. So there's more training data to classify than at species level. And also they're very important indicator species in the ecosystems. So we found we could detect automatically if your algorithm and if your artificial intelligence algorithm over 100 species there for this site, so quite nice. And what this graph in the right here shows is the different species regions across the site. So as expected, more species in the intact secondary forest, and surprisingly, similar levels of species regions in the old agroforest and degraded sites, But here the caveat is that the degraded sites, they have different species composition. So as you degrade the site, it may change the composition of the species over there, and that's not always good. But also may be that the degraded sites, the region there, they're surrounded, so kind of a matrix of forest, agroforest, and degraded sites. So birds are very mobile, so they may be moving throughout the sites. So in the end, you may detect the birds that are very mobile in just different other sites as well, including the degraded. But in the Ongo agroforest, you only have a very low species richness because in the end, one of our recorders there in this Ongo agroforest, they malfunction. So they did not collect the data as they should. So that reflects. So because you collect less data, that reflects in the final number of species you could detect there in this site, unfortunately. So in the future, we have to deploy more sensors in this site to really get to maybe what really reflects the species richness of the young agroforests. Okay, so let's move to the main takeaway message of the presentation. So the Sumatran tiger was captured in the video, like I said. So this is a critically endangered species, was captured by both cameras in the same night, about 8 kilometers apart from each other. So it's the first sighting since the project started. We detect 8 species of mammals with the camera traps, so also some birds. The soundscape analysis, this 24 variation and analysis could reveal both in the audio but with ultrasound spectrum. So we're talking here both about birds, frogs, insects, but also bats. They reveal difference in the sites and kind of support the restoration success, with all the agroforest sites being more similar, with similar soundscapes to secondary forest control plots, for example. And overall, we detect over, as you see there, over 100 bird species detected using the existing classifier. And this automated approach also proved to be more efficient than manual validation. For example, we did a little case study there comparing what we could identify manually in the video data and what could the algorithm classify. So we get much more detections doing with the algorithm than manually reviewing the data. And also this kind of analysis could reveal some of the behavior of the species over there, because by the time they are detected, both in the audio and the video, we could know where the period of the fish is more active. So it might be indicated the time they're going out to hunt, for example, Sumatran tiger, the time they go out to eating or going out of their nests and these kind of things. So quite interesting sites to also learn from this analysis. So the Panthera, the Sumatran tiger is a critically endangered umbrella species, and it was used for marketing and storytelling purpose by CO2 operated. The video ended up going viral on social media. So we got many sites from the in-situ sensors as to the species region, as I showed, but how the species are moving throughout the landscapes, the presence of prey, predators, activity patterns, so what time of the day the species are more active or not, some behavioral analysis. And that's interesting because, for example, if you use just some one tag or another, like such as eDNA, you may not get some insights about the activity level of the species, what time they are more active. You may just get the presence and absence of the species. So that's why it's interesting to couple these different technologies to get a better holistic view about the biodiversity in a region. And overall, our system offers a much more than biodiversity monitoring. So it's an interactive storytelling tool for NBS projects to demonstrate bioimpact. And that's shown not only with our rigorous scientific analysis, but also with the videos and the soundscapes that can be produced for storytelling. So you see the different videos over there, the Sumatran tiger walk around. So that can really help with storytelling for different projects around the world, right? Because these species are very charismatic. And with that, I thank you, and I give back the presentation to Emilia. If you want to reach us out, that's the email. And we are based in Germany right now in Saarbrücken.
Thank you very much, Leandro. It was really insightful to see all the data that you collected and how you analyzed it, and especially to hear the different soundscapes and to actually really hear the differences between a degraded landscape, an intact forest, and an old agroforest. I think this is really powerful. So now to begin our Q&A, we will start with the chat where we have one or actually two questions from Tom Herman. We can start with the first one, which I assume is directed to Paul, that Stand for Trees would be interested in listing your project. Paul, how could they proceed?
Sorry, what did you say?
Yes, Stand for Trees would be interested in listing your project. How could they proceed? Maybe, I guess the first step would be for you, Paul, to write down your email in the chat.
Yeah, I will do that.
And also, Tom would be interested to hear that's towards Leandro about the pricing for biodiversity measurement services and also for the carbon offsets that we previously heard about.
Somebody sneaked in.
Yeah, kids hijack all meetings, even the most official ones, especially.
Now, for my pricing can be short. We are getting between 25, 30, 35 euro already for 1 ton of CO2. So 1 carbon credit, that's between 25, 35 euro, depending on my negotiation skills at that particular moment. I'm convincing them, but that's mostly between 25 and 30. That's what we get. For the biodiversity work, I think Leandro can answer that one.
Yeah, actually, I'm a scientist in the company, so I guess I could move that question to Fabio and Werner that are here in the talk as well. They also work in the biometro, more in the Felix team. So
yeah, thank you, Leandro. I will just hop into that question because I saw it in the chat already, and I was about to answer straight on that. That's an absolute individual thing that we have to talk through, because it depends on how many cameras will we need, how many microphones, what will be the services, how long will be the measurement and all that. So this is a very individual thing that we have to calculate for each project, and there is no baseline that I could say it's about that amount of money. But yeah, I'd be happy to answer you, Tom, if you want to write me, or I send my email in the chat, right, as an answer, so we can stay in contact, and I'll be happy to answer your questions in an individual talk.
Thank you, Vanna. We have more questions in the chat coming up. I would just like to mention at this point that everybody is able to unmute themselves if they would like to ask the question directly. So while you're thinking of more questions, I'm proceeding with the next one in the chat, directed to Paul from Manje Kumarasamy. I excuse myself if I'm not pronouncing the names correctly. Curious to know, Paul, do you plan to expand this approach internationally? Do you have a method to identify potential regions and customers? And are you working with government bodies to adapt a regulated biodiversity credit system?
Yeah, I get this question quite often about the international component. So far, we haven't tried yet because Indonesia has 25 million hectares of degraded land. So we're still busy in Indonesia, but we may look in the future into other countries, and yeah, but we haven't given it a thought. Yeah, Vietnam would for us be a second place to start because we have a good network there as well, and it's therefore important indeed to work with government bodies in the different countries. We also work with the Ministry of Backward Regions and Transmigration in Indonesia. So with them, we also identify areas where to work and where it's most needed for the local people to benefit from these projects. So that's indeed important. And yeah, a biodiversity credit system, I'm not sure what you mean, but I know we are certified on a Plan Vivo, and there will be a biodiversity standard coming out soon from Plan Vivo. So I don't know exactly if, but we may get involved into that with the bioacoustic work done by Biometrio, but that's still under discussion, what I understand. But if that's the case, then we would be able to sell biodiversity credits as well, which would be great. So hope that answers your question, or why is it? It's gone. Yeah.
Hey, Paul, thanks for answering the question. No, the reason I was asking the final part was, it's just, we've seen what's gone with the carbon market, where it's not regulated and the pricing is all over the place, and there's a lot of things that are done bad, right? So I think what you have is amazing, and if you engage initially from the beginning to take on more of a regulated approach, I think it would be beneficial, right? Because you don't want to be reinventing that whole situation where it's all of a sudden, companies and people are claiming, and countries are claiming biodiversity credits, and you got double materiality, like all these other things that are taking place, right? You want to avoid it. That's
No, that's
just my 2 cents.
Yeah, no, that's true, and that's why Plan Vivo is really good to have, because they're really careful, and every year the annual report we have to write, it's really a headache because they ask so many detailed questions, which is good, and we manage to answer them every year, but they're really on top of it to avoid us to do things which could go bad in the news. So yeah, so far we are quite happy with Plan Vivo standard, even though it's tough to get your annual report approved.
Yeah, and just 2 days ago, the Vera came up with a standard as well. It's a public consultation there right now too. So it may have in the end several, like we have for the carbon, several standards, and they're all in the phase of consultation right now. So it's good. There's room for improvement, and for them to learn the lessons, what they did wrong from the carbon market, and then make just nature biodiversity credits maybe better in the future, right? So that's the goal, I think.
So thank you, Paul and Leandro. Moving on to the questions in the chat. There's an interesting one on creative and political uses of these soundscapes to raise awareness and to make more bridges between scientists and arts activism. So Paul, you're a bridge yourself between science and activism and work on the ground. So maybe Paul and Leandro, you can also share your thoughts. I see Fabian already commented on this interesting question and comment.
Yeah, for me, I've heard it now for the first time, the soundscapes. So I was asking for it, even if it would be possible to integrate it into our website. We are developing a special page on biodiversity. So I was really also very amazed to hear all the different sounds that you presented, Leandro. So I was really happy to hear that. So I think that's one. And indeed, making an infographic on these results for me is also now being an academic in my previous life. trying to make it into a language that can be understood by everyone. That's really, I found it's a big challenge. But for sure we can make it, but it needs time. And I don't know, I've been in discussion with Leandro and Fabian and all of you. So how to, with all this wealth of information, how do we bring it into the audience on a more wider scale?
No, yeah, for sure. I do agree. You should strive to have better ways. So the scientific analysis is important for the, for the scientific point of view of having really clear data. That's important to bring transparency to the projects. But I also need to show how this big public to understand, right? I feel like Fabian told you a little bit. There's several efforts in that direction because there's a little bit difference about the ecoacoustics and the bioacoustic fields. The ecoacoustic fields is a field that was proposed more recently with advances of better sensors, with artificial intelligence. So the bioacoustics has been around for a longer time, but since the ecoacoustic paradigm it changed about 10 years ago, it came out, people start to see more interaction between these audio specialists from the biology field with artists. And that's important because come up with some very interesting projects, ideas to show up your projects. Or even like concerts being done with soundscapes. So using these natural sounds, these natural soundscapes to bring out holy concerts for the people to raise their awareness about climate change, biodiversity changing. And I saw that project, for example, Utah, there is a residence orchestra there at Utah State University, where they come up with this project. There was physicists involved in narrating the story, and there was this music made of soundscapes where they could play the music and talk about climate change, biodiversity conservation. So it's one of the best examples I saw about like bringing art and science together. And people are aware of this in the field, like the first Ecoacoustic Congress took place in Michigan in 2016, was lucky to be there. And it was nice to see there was not only scientists there. So we had a lot of talks with artists, musicians, people working in different fields like biology, archaeology was over there. So people are aware of it. You just maybe have to get really more collaboration and more work on it, like making better to showcase this cool data to everywhere and make everyone to understand.
But I think your sounds from the 3 different areas are very lively for people who don't know much about the biodiversity things. I think that's a really good one that we can use for our marketing.
Yeah, for sure. Yeah, I have to share these recordings if you're the one you asked about the different environments, so I could put in the infographics. It's probably going to look quite cool in the website.
Because I talk a lot to companies and they like these kind of things where it's easy to understand the differences. Yeah.
It makes also probably the data and the concepts much less abstract.
Yeah.
And we have like from emerging research on human nature connections, the data show that it's emotional engagement through the senses, through the different senses is also really important. So these types of let's say multimedia products coming out from biodiversity research can help on so many different levels to reconnect us more with nature. So thank you very much for your comments. We have, let's see if we manage in the next 5 minutes to address some of the other questions that we have in the chat. One from Monica to Biometrio colleagues. Where can we find the results on the camera traps from Paul's projects and or more material like this from Biometrio? So do you plan to make such types of products accessible to the wider audience?
Yeah, we will, as I said, we are developing a special page on our website where all these videos will be showcased. I have a YouTube channel where but it's not very well organized yet. But I'm trying to find somebody who can do it for me. So then it's really time to make it a bit serious and make all these videos available to people who want to see it. And yeah, so that's the idea for the future.
Yeah, the same for biometry. We're working with some designing company to make our dashboards looking better. So we analyze all the data in the cloud, we visualize some of this data in the cloud. We still have to work a little bit better on the design to really make them showcase just different projects in a website or some platform. But we're working on that. We don't have, unfortunately, some link to send you right now, though. Only the website.
Yeah. So,
Thank I'm
coming.
building on the question of videos and materials. There's one to Leandro concerning video data and its processing that can be very energy intensive. How are you addressing this challenge?
Yeah, like I said, we do it in the cloud. So for us, it's been working quite well with both these. We have two very large data flows, or maybe three if you count the satellite remote sensing. So we did a pretty good job in automating all this process. So as the data comes from the field, you retrieve metadata and these kind of things, and then we run these algorithms in the cloud to the final goal of getting the species detection, right? So once you have the species detection, we can try to calculate these other indicators like species richness, the species, the functional traits of the species, functional holes, landscape integrity indicators, the soundscape indicators, the ecosystem indicators, so on. So we rely on cloud computers. So that's the best way you have done so far. So we store our data in the cloud. Of course, we need a lot of space, but we have a deal with some companies that provides us with enough processing power we need to run our projects. So for running this algorithm, sometimes, for example, I think for running the data Poll Collect, it took us 1 week of data processing for both the audio and the video data. So not that much.
Thank you. Thank you, Leandro. I'm sorry, I have to rush through the last questions. Moving on to one from Pavlos, asking or starting a comment first that the key standards and VVBs are in support of digital MRV tools in monitoring, but how does that work in practice? Have you demonstrated that these observations can actually be used for project validation and verification? I guess this question is open to both Paul and Leandro.
Sorry, I was answering one of the questions in the meantime. Sorry. Repeat again, sorry.
Yes, if the results now coming out of digital MRV tools, are they useful in practice for project validation and verification?
Okay. Yeah, I hope so, because I think bioacoustics are really, because it's a very animal friendly way of looking at biodiversity instead of putting up nets and traps. And so I really hope that it will be accepted. And I think Plan Vivo is looking into this issue of the bioacoustic methodology. So then it would be, if they agree, then for sure Plan Vivo would be one of the first bodies to accept this methodology, and they are looking at us because we seem to be first one to do this. So we will certainly promote this kind of methodology within Plan Vivo.
Great.
And I think it's really good because it's compared to the traditional way of setting up traps and causing a lot of stress among the animals. I think this is really the way forward, and it's amazing what we achieved in just 1 month. So yeah.
Yeah, good, Paul. Yeah, actually, I think it's bringing more transparency into the projects than collect the data manually. For example, it's the traditional methods. Because imagining all these recordings you make from the audio sensors and the camera traps, we store that in the database. So anyone can have, if someone wanna check the results you have, they can try to rerun the analysis. Just rerun the scripts. You're gonna see if you're really getting the same numbers of species and you reaching the same conclusions. So actually bring more transparency because the data is archived, so it creates like an image of how that place it looks like. If you preserve that data, it can be here forever now, like a voucher for a museum, right? Just sound recordings, just camera trap videos. So it's like storing sounds and data for perpetuity. 100 years from now, someone, if they're interested, they can rerun the analysis and see what results they can get. So actually can bring more transparency to the project.
Thank you. And before we close, I guess this is the question of the session. Finally, what does a tiger have to say about carbon credits? Maybe 2-3 sentences.
Yeah, I think Tiger is quite happy because of our carbon credit income, we can restore ever-growing areas, and the Tiger already using our sites to move from one forest area to another, where he in the past probably wouldn't have done that. So I think it makes his life easier and also more protective by using sites between two patches of forest to wander around.
Thank you, Paul. Leandro?
Also with Paul, and the tiger's umbrella species you see, it can be used so you can say a lot of biodiversity. It's like if there's a tiger, it also means there's a lot of birds over there. It may also means there's a lot of insects and all these other biodiversity factors. And maybe the most important factor in this project specific is also bringing benefits for the local communities over there, right? To help fight poverty and just problems we have in the tropical region.
Thank you, Leandro. So I guess what the tiger says is that when you do a carbon project right, it can really benefit nature and people at the same time. So thank you everyone for joining us today in this session on what does a tiger have to say about carbon credits. This session was recorded and will be sent to all who registered, together with Paul and Leandro's emails. If you would like to send them more questions, continue the discussion, or start a collaboration, you will have this information very soon. So thank you, everyone. I hope you have an inspiring and productive rest of the Climate Week.
Will the chat be saved, or because there are so many interesting links they put up?
Yes, it should be in the recording, but I also noted them. Paul was yes. I see my colleague Jill replied yes, so we have it all noted down.
Thanks everyone also for all the links that I see passing by.
Thanks everybody. Thanks for joining us.
Yeah.
Thank you.